Hi everyone. In this video we're going to be talking about some logical concepts when classifying statements. So we're going to be talking about three concepts: tautology, self-contradiction, and contingency. So let's take look at a few statements which exemplify this. We're going to start with tautology. Now there are a few examples of this, but for these examples of at least of tautology and of self-contradiction, I'm going to be using two famous laws of logic, which are the law of excluded middle and the law of non-contradiction. So for tautology, I'm going to use the law of excluded middle. So there's this law of logic called the law of excluded middle, which is stated as follows: P or not P. And so let's just construct the truth table. As you can see, we only have P here. So in total, we only have two truth values, true and false. And so since we have a not P right here, the not would just get the opposite truth values, and the not is the main operator modifying P. It's not the main operator, but the not takes priority over the P. So it takes the opposite truth values, false and true. Now the main operator here is OR. And remember, the OR operator is true whenever at least one of these things right here, the disjuncts, whenever one of the disjuncts are true. So right here, P, the left disjunct, is true, so we give it a true, even though the negation is false. Right here, although P is false, as you can see, the negation here is true. So the OR operator is true. And so as you can see, both of these truth values are true right here. And I'll just highlight it gray so you can really see the point. So both of them are true, and that means that it's tautology. It's always true. So let me give you a bit of background on what this says. This is P or not P, and what that means is something either is or not is. So I'll give you an example. My name either is or is not Brian. In this case, it is Brian. I either am or am not a student of Harvard. In this case, I'm not a student of Harvard. I either am or am not a boy. I am a boy. I either am or am not an elephant. I'm not an elephant. So on and so forth. So that is just doing a recap. This is here I'll write it down. This is the law of excluded middle, and this is a tautology. Okay, so the next one I'm going to give an example is of the law of non-contradiction. So the law of non-contradiction is going to put this into perspective. The law of non-contradiction is formulated this way: not P or not P. And so this looks really similar to the previous one. So instead of P or not P, we have not P or not P. And so the way remember the way negations work when we talked about negations earlier. Yeah, let me line this up right here. When we talked about negations earlier, we said that whenever we negate an operator, we always get the opposite truth values. So just by looking at here, if we have this exact proposition right here and the truth values are true, true, then if we negate that operator's truth values, then we should get false, false. And so we get the exact opposite truth values. And so if this is a tautology and it's always true, then we get for the opposite values, we should have a name for something too. When something is always false, we should have a name for it, and we do, and that's called self-contradiction. So just like previously, I'm gonna write the truth values right here. So first, I'm gonna give the name. The name is the law of non-contradiction, and the name for classifying the statement is this statement is self-contradictory. And for the last one, contingent. Contingent means that a statement has at least one value that's true and at least one truth value that's true and at least one truth value that's false. So this isn't self-contingent because it doesn't have at least one truth value that's true, and this isn't self-contingent. This isn't a contingent, not self-contingent. This is not contingent because it doesn't have at least one truth value that's false. So I'll just use P or Q. P or Q. And here we'll get true, true, false, false, true, false, true, false, true, because they're both true. You only need at least one true for the OR operator. True, because the left disjunct is true. True, because the right disjunct is true. And then false, because neither of the disjuncts are true. As you can see, right here we have at least one true and at least one false. And so this statement is contingent. So now I've shown you how to classify statements, and so I'll see you guys in the next video.